Good afternoon, everyone. Am I audible? I was about to do downloads. Am I audible? Hello. Okay. In DOS 2, where did we leave? DOS. Sure. Till where we have done this water tank? Till where we have done? We have completed till moment we have done area steels we have done. We have the moment distribution. Till here. Moment distribution. This one. Till here. Okay, Ashram. Once we have completed our moment distribution, we have done this. How much is our? I think this also is wrong, but then I showed you which one is the correct one. And then the direct tension in the long wall, direct tension in the long wall, direct tension in the short wall. We had calculated. We had calculated the total depth 300 mm. Okay. So now we will be designing the longer wall. After we have known, we have calculated the, okay, okay, after we have calculated the depth, we will now design the longer wall. Design of long wall. Now in the design of long wall, you see here the moment we have calculated already, which is your 63 kilonewton meter. Moment 63 kilonewton meter, we have tension 54 kilonewton for our long haul. Now the modified moment will be how much? Our modified moment will be 63 minus T into X, where our T is the tension and this is the moment actually due to tension. T into X. X is the distance of the reinforcement of bars. I think I have explained this thing over or in section A. Okay, whatever. So this is the moment due to the tension, which is your T in this side, you will have your moment. In the beam, both the sides you will have, okay, here both the sides you will have your tension on the beam. Okay, so this is your moment due to the tension T into x. Then we can calculate it in this way. The modified moment at support, which is 63 minus 54 into 0 0.1, which is 1 is your distance of the reinforcement from the tension. Okay, annotation if I show you. Okay, this is the tension here. This side also is the tension. So we are having, yeah. So this is the reinforcements are here. I'm not able to draw. This here the some of the reinforcements will be here. Bars 1, 2, 3, 4, 5. In this way, okay. I'm not able to draw here. I'm showing. Can only this is the reinforcement. Okay, so this distance from this tension till the reinforcement of bars, this one, this is x, and x is given by your x is equal to how much? 100 mm. Okay, these are your movements here. This total from the center till the edge bottom it is 150. This total depth is 300. This entire depth is 300. Okay, so we are having here this T, the tension, into this distance from the neutral axis, or the distance from the tension till the reinforcement bars, the moment is how much? This one is your moment T into x distance, that is 100 mm, so zero point 0.1 meter. So we have got this to be 57.6 kilonewton meter. Now we can find out the area of steel. We can find out the area of steel for moment. It is given by m by sigma st. This one, okay, m by sigma st into j into d. Now, what is a moment? The modified moment we have got it to be 57.6. Then we have sigma st is your 130. We know from that table I told you from high school at the very beginning we had this one. This one, sigma CBC 10, sigma ST 130. Okay, from table 2 and 4 of class 4.5.2.2. Okay, we had got these things. We had already noted down for our what is our this thing, sigma ST, sigma CBC. So now here for the area of steel for movement we require what? M by sigma ST into J into D, where M is we know 57.6, sigma ST is 130, J is we had calculated there when we had noted down from the table the sigma ST and sigma CBC value. We have also calculated this J and D. Okay, so we know these things. We have this much. These are the values. So the area of steel for movement is we have got it to be how much? 2058.42. And we have now area of steel for tension is given by sigma st. Wait, huh? I by T. This is T. Okay. T by sigma st. This is T. This should be T. This is T. Okay, so AST for moment was m by sigma st into j into d. AST for tension is how much? For tension it is T by sigma st. So 54 into 10 to the power 3, we have got our sigma st for tension is 415.38. Now the total area of steel is how much? This plus this. That is the area of steel for moment, area of steel for tension. So we have got our total area to be 2473.80. Now we will be providing 20 bars of at a spacing of 120 So the area of steel required will be how much? Area of the bars pi raised to by 4 by the spacing into the per meter. So it is 1000 here. So we have got the area of steel required to be 2617.99. Now this is the area of steel required after giving the spacing and the number of spacing in the diameter of bars. We have got the this much area of steel is required at the supports of the long wall. These are design of long wall. These are at the support. Okay. At the support. Then now at the center, so at the support we have got our area of steel to be how much required area of steel is 2617.99. Now at the center, now at the center, how much you will get? At the center we have moment is this much 58.5. We have the tension to be 54 kilonewton. Tension is 54. This one. Bending moment at the center of the long wall, we had calculated how much it was 58.5 kilonewton meter. Also, okay, modified moment is equal to m. Okay, so now for the center we had, I showed you here now the moment which we had calculated already earlier. For the center is this much, 58.5 kilonewton meter. Then we are having how much? T is this much, so modified moment is m minus t into x. Same thing, T we know this much, x we are having. We are taking it to be 100 mm. Okay, so area of steel for tension is T by sigma S T. Area of steel for movement, area of steel for moment, area of steel for tension. Area of steel for moment is 189,761 mm square, 415 is 1 mm square. Okay, so now what is happening? After that, again total, we will find out total area of steel for moment, and the calculating both this, we will have area of steel for the moment and area of steel for the tension. Total area of steel is 2313. This plus this, 2313. Now the area of steel provided is how much? Pi d square by 4 into spacing, we have got this much. So the area of steel provided, this is the total area of steel provided. So we have seen what? Our this provided area of steel is greater than the required one. 2618 is our provided. 2681 is the provided and 2617 is our area of steel required. So this requirement, we have provided more than the required value, and so it is good. Okay, this is okay. If our provided reinforcement area of steel would have been less than the required, then what we could have done, we would have changed the diameter of the bars, spacing. Okay, a diameter of the bar, spacing will change, and will again check. We had to check it again whether it is now your requirement is fulfilled or not. Okay, so in this way we have provided the area of steel. Now a distribution steel, minimum area of steel for distribution bar is 0.24%. Okay, so now for the distribution steel, minimum area of steel for distribution is always 0.24% for distribution of steel. So D, we know how much half of D is the depth, how much 300 by 2. So two zones are there, right? Suppose this is the, if this is your tank, we have here waters are there. So we have what? This is your, this wall is your, this wall is your liquid phase. Liquid phase, and this outer phase is your, this is a liquid phase, this is the outer phase. Okay, so there are two phases here. Now we have two zones, that means, okay, so this side, this thickness is 300, so that is divided into two. This side 1, this side 1 half, that is 150 mm, 150 mm. So the reinforcement will be placed in that way. So now we have the first zone will be how much? The percentage of steel is 0.24%. Okay, so 0.24% of 150. So that was per meter. So 1000, the width is 1000. So area of steel required is how much? 360 mm square. Area of steel required is this much. Now we will provide some distance distribution bar. So 10 mm, 12 mm bars you provide. So 10 mm here it is designed as 10 mm bars are taken, diameter bars are taken at 210 mm. spacing. Now the area of steel provided. Now the area of steel provided is how much? We have calculated it to be 3739.9. Okay, mm square. So now that is greater than the required value. This was the required one, 360, but we have provided it the area of steel to be 373.9 square. Okay, so it is how much? Therefore, it is okay. Our spacing, our whatever the diameter of the bars we have taken, all those are sufficient. Okay. Okay. So now the design of the shorter bar design, this will be designed along shorter wall at support. Now same thing again, will follow the same thing like in the longer wall, like that only in the shorter wall we will provide this same calculations we'll do for design along the shorter wall at support is how much? At support, your moment is 63 kilonewton meter, your T is 81 kilonewton. Now the modified moment at center is M minus Tz. Same thing, then again we know for shorter wall we had how much? Moment is 63. Our Tx, the tension, the moment due to tension is how much? T into x. So T is 81 we know. T is 81 into 0.1. Okay, so we have how much? 54.9 kilonewton meter. 1 minute. Okay, so it is 54.9 kilonewton meter. Here again, same procedure. Then again, area of steel for moment along the short wall at the support we have area of steel for moment. Area of steel for moment, same procedure, area of steel for moment, area of steel for tension, and then the total area of steel required. Then total area of steel required is this much. We'll provide a spacing, we'll provide the diameter of the bars, we'll consider area of steel provided will be, we'll calculate now, and then here also it seems to be greater, 2617, and here the total area required was 2585. Okay, that is greater to 285 or you can calculate it yourself and check. Okay, so this is how much? 2617. This area of still 2617. This is 2585. 2585 maybe. I don't know. You calculate and see. So area of steel provided should be greater than the area of steel required, since it is okay. So okay, done. Now again similarly at the center we'll see. At the center of the shorter wall again same thing. Moment is already calculated. Moment is 9. Our T is this much. So modified moment we'll find out at the center. Area of steel we'll find out. Area of steel, area for tension we'll find out, and then area of steel for movement we are having. Same formula M. This thing for shorter wall we have already calculated here. The moments. Okay, if you check, it is done already. For the shorter span at the center, we know the moment and the tension. So it is different. Like it is for 9 kilonewton meter and K is equal to, sorry, T is equal to this much. So we have area of steel for moment, area of steel for tension. Total area of steel required is this one, this plus this, area of steel for moment, area of steel for tension. We have got area of steel required is greater than area of steel provided. Okay, okay, 1 minute. So the same thing. Okay, again similarly distribution bars are checked, then we'll go for cantilever action. Again same thing, distribution bars are checked where area of steel provided is greater. We have found that area of steel is greater. Please give your attendance. I think this is for this is, um for 64, 64, 65, 67,
Present, ma'am.
69, 72, 73, 74, 74, 75,
Yes, ma'am. 75.
76, 77,
Yes, ma'am.
78,
77. 77.
78, okay, 78, 81, 82, 83, 84, 85,
Yes, ma'am. 85.
88, 89, 91, 92,
Present, ma'am.
93, 93, 94, 95,
Present, ma'am. 95.
96,
Yes, ma'am. 96.
97, 98, 99, 102, 100, 100, 102, 110, 112, 115,
Yes, ma'am. 115.
116, 116, 117,
Yes,
119,
ma'am. 117.
119, 121, 122,
Yes, miss. 122.
122, 123, 125,